Hi, this is Brent Ritchie, and I'm going to talk for a few minutes on the standard normal distribution and how we use the table to look up values. First of all, we have a distribution. Looks like this, often referred to as a bell curve. And the total area under this curve is 1. So what we're interested is in finding areas, parts of this curve. So areas less than 1, like what is that area over there, and what is this area over here, things like that. And of course, every data set has a different mean and a different standard deviation. So in order to make this process, to simplify this process, we standardize everything, and we do that with a standard score. So if your standard deviation is 10 and your score is 20 away from somebody else's, instead of saying it's 20 away, we'll say it's 2 standard deviations, because each standard deviation is 10 and you're 20 away. So you're 2 standard deviations. Excuse my penmanship here. It's terrible. So a standard score takes, as in the example I gave you, your score say is 100 and the average score is 80 and each standard deviation is 10, then this formula would give us 2, meaning you're 2 standard deviations away from the mean. Now, it works for, the nice thing is this works for any standard deviation. If your standard deviation, say your mean, is 5 and your standard deviation is 2, and you have a score of 9, or well, say 13. There's your score, 13. How many standard deviations away from the mean? What's your standard score for that? Well, we take your score minus the mean, which we know this problem is 5, and then we divide it by the standard deviation. So there you have a difference in 8. Each standard deviation is 2, so you're 4 away. So we're going to standardize data first, and then we'll learn where you fall under this curve, and the percentage that fall above or below that amount or in between amounts. There are really 4 possibilities you can boil it down to. I think this simplifies it the best. You can be looking for the area to the left. So if this is my curve, my distribution of data, and this is the score we're interested in, falls here. Here's the mean in the middle. You could be looking for the area to the left, the people that are less than that score. Fortunately, the table we're going to show you today gives you the area to the left. So all you have to do is look up your z-score. Just look it up, and it will give us our answer. And I'll show you how to do that in a little bit. The next possibility is just the opposite of that. Here's our score again, but now we're interested in who falls above that score, who falls to the right of that score. That's the area to the right. Now, since our table gives us the area to the left over here, and the total area under the curve is 1, we look up our z-value. That gives us the area to the left, and then we subtract it from 1, and that will give us our area to the right. Subtract from 1. That will give us the area to the right. Then we have the case where we find the area between. Here's my curve again. my distribution of data. Suppose I have a score here and a score here, and now I'm interested, what percentage of the people fall in between these two scores? In this case, we looked up both scores, both standard scores in our table. So we look up both, we get the two different areas, then we subtract the smaller from the larger. And that will give us the area in between two scores. Finally, we have the opposite of that. And this one doesn't get used as often. And that's the area outside of two scores. And you can probably already figure how we're going to do this, since this is the opposite of the one above it. And we know the curve, total area of the curve is 1. If we know how to find the area between those two, then we certainly know how to find the area outside. Call this area outside. We do that by repeating the process right above. First, you find the area between. And then you subtract that from 1. Now, how do we look these up in our table? Suppose we have a z-score. Let's look up a few. A z-score of 1.33. So that's 1.33 standard deviations above the mean, because it's positive. Let's look at our table. Right here. Notice the table, notice the picture up here shows us that the area the table gives is always the area to the left. Now, not every table out there, when you Google them, is going to give you the area to the left. Some are the area to the right. They all work, but you need to know what you're starting with. And typically there's a little diagram on there that shows you what the table's given. The table I use gives area to the left, and we work from that premise. There's 2 pages to this table. You have the negative z-values here, the positive z-values here. We're looking up, in this case, z equal to 1.33. To do that, you first look up your whole number and your first decimal place in this z column right there. So we come down to 1.3 right there. Then we find our second decimal place, in this case another 3, and you find that across the top. So that's the second set, it's 0.03. We find that right there. So we come down this column here, and it's the intersection of the 2 columns. Let me extend my blue arrow from 1.3 over. We find our area to the left of 1.33 is 9082. So if we had a curve, normal distribution, look like this. Here's your z-value, 1.33 standard deviations above the mean. The percentage of data that falls to the left of that is 0.9082. 0.9082, about 90.82% of the data falls to the left of z equal to 1.33. So that's how we read the table, and then we go back, depending on the problem, we use one of those 4 methods. If we're looking for the area to the left, we're done. when we do this. If we're looking for the area to the right, we subtract that from 1. Now, suppose we have a negative value, negative 2.54. How would we look that up? We would go to the negative side of this table. We would find negative 2.5, and the second decimal place 0.04 right there. We would find the intersection of the two. See, it's right there and down to here. And the intersection of those two is 0.0055. So the amount of data that falls to the left of negative 2.54 so it's 2.5 standard deviations below the mean. So that's way over here. Very little data falls over here. That's why we got such a small number. That little area there is 0.0055 out of the total of 1, or about 0.5%, a little more than 0.5%. So that's how we read our table, and that's what we're going to use to solve the problems in this module.